All right, so recording's on, so I'm gonna go to our screen. All righty, so we're gonna start in 9.5 again, doing the logarithmic properties. I probably called it properties of logs the other day. So we're gonna go back through these four properties, remember, product rule, power rule, quotient rule, and rewrite these, okay? So we're going to express in terms of sums and differences. Okay, so I'm going to pick up about number 9. So this one is ln of 6 divided by 7 x to the 7th y. So remember the other day I said if they're on top, when we rewrite them, they'll be positive. And if they're sitting on the bottom, when I rewrite them, they'll be negative. And then you got to realize that that is actually 3 factors on the bottom. You got the 7, the x7, and the y. So when I rewrite this, I'm going to come out, distribute the ln to everybody. So the one on top is going to stay positive. Everything on bottom, I'm going to distribute the ln to and make them negative.
Is he cutting out for everybody else too, or is it just my internet?
He's cutting out on me a little bit too.
Okay. I ain't getting no warnings on mine. Usually
I can hardly see what he's writing.
Oh, it's showing up pretty big on mine. Is it not y'all's?
I can see you, but your voice is getting
Your
pretty
audio
robotic.
out.
It's
Okay,
pretty bad.
I'll try to.
Yeah.
I don't know. Let me look at my.
Okay, I got mine fixed.
Okay, yeah, because my audio's showing all right. All right, now remember, we've rewritten it as sums and differences, but there's one more thing I got to do to this problem. I cannot leave my exponent sitting up top, remember. So right here, I got an x to the 7. So what I need to do on that 7 is utilize that power rule and bring the 7 down to the front and write this part as a product. So I get my ln to the 6 minus my ln 7 minus 7 ln x and then minus my ln y. You know, that's it. Nothing else I can do to that. So this is probably one place in math where you get really long answers sometimes, okay? All right, let's try this. It is a log square root c to the 9th power d. So really, like on the problems we did the other day, your first move, you want to get rid of the radical on this. So I'm going to rewrite this without the radical. Let me let one in real quick. Now notice, everything's under the radical. So when I rewrite this, I'm going to put my C9D in parentheses and rewrite that radical. So the top exponent would be a 1. The bottom exponent would be the index, but remember there's no number there. So if there's no number there, we always treat that number like a 2. So anytime you rewrite a square root radical, its exponent will be a 1/2. Our next move was order of operations is to take this 1/2 and distribute it through those parentheses. So that's going to give me C 9 times 1/2. Remember, you can just multiply straight across and make that what, a 9/2. So C becomes a 9/2. D, since there's no exponent by it, we treat it like a 1, and 1 times 1/2 makes the D have an exponent of a 1/2. Now what we got to do, since you got 2 factors being multiplied, we're going to rewrite it as addition. So you get log C to the 9/2 plus a log D, whoops, log D to the 1/2. So remember, you always separate a product out as a sum, and we separate our division out as differences. All right, y'all, one more move. What's that going to be?
Thought we were done with it.
Oh, we're pretty close. We're pretty close, but there is one more move I got to do to that.
Gotta move
Are we
the
gonna put the
exponents to
exponent
the
on the,
front.
put the
There you
exponent
go.
on the outside?
So both of these exponents have to come to the front of those logs. So I get what, a 9/2 log C plus I get a 1/2 log D. So rewrite them as the sums or differences, and then if you got those exponents, you got to take care of them using that product rule, okay? So all they're doing really is making you do work in the beginning before you can get to those logarithm and properties. Whoa, y'all, here's a big one, okay? You ready? Log base C. This is a big radical with a 4th root. On top is a M16, N20. On bottom is a C5, A5. So this is like the granddaddy of these problems here, okay? So this thing, we got a radical here, so our first move, we want to get rid of that radical. So I'm going to bring my log C over, and I'm going to put everything inside some big parentheses. I'm going to put the M16, N20 over the C5, A5, and the exponent I'm going to give this radical, since that's a 4th root, this will become a 1/4. Okay, so always write these radicals as a fractional exponent. So now, y'all, we got rid of the radical. This outside exponent, the 1/4, has to be distributed to everybody inside those parentheses. So that's going to give me a log C. So let's see, 16 times 1/4. So 16 times 1/4 will give me 16 over 4. And we can actually make that, what, a 4? So I get M to the 4th. How about the N? You got 20. So basically, you're going to divide 20 by 4.
That's gonna be fine.
Yep, that'll give me a 5. Now the bottom's going to be a little trickier because neither one of these 5s will divide by 4. So let's see what we get. 5 times 1/4 will be 5/4. We cannot simplify that, so I'm going to get a C to the 5/4. And A is going to be the same way since it's a 5, so that'll be a 5/4 on my A. So we really haven't done anything to the problem other than rewrite it without the radical. So now what we want to do is rewrite it as sums and differences. So remember, if it's on top, it's going to be positive when we rewrite it. If it's on the bottom, it's going to be negative. So this would become a log C M to the 4th plus a log C of N to the 5th. Now, since the other two are on bottom, that's going to be minus a log C of C to the 5/4 minus log C of A to the 5/4.
So that C was always little.
Yeah, and that's my little C is my base for my logs.
And now we've got to move all them exponents.
Bam. And is there any, so I'm going to move exponents, but is there anything else y'all might notice about this?
So do the C's
Log
cancel?
C.
Well, right here, you got a log C of C, right? Raised
Yeah.
to an exponent of 5/4. And if you remember yesterday, anytime we had a base match that result, the answer was always the exponent, right?
Okay. Yeah.
Because remember, if I
Right.
bring that 5/4 to the front, that log C of C becomes a 1, and 1 times the 5/4 will keep it as a 5/4. So if you realize that the log C of C part is just a 1, then you can replace that step with the 5/4. I'll do it the long way. So we're going to bring the 4 down to the front like Kelsey said, and that's a log C of M plus a 5 log C of N minus 5/4 log C of C minus 5/4 log C of the A. And then at this point, you'd say, oh, damn, that equaled 1, that log C of C. So if you don't convert it to the negative 5/4 at this spot, you definitely got to do it at this spot. So that my final answer will be 4 log C of M plus 5 log C of N minus 5/4 and then minus the 5/4 log C of A. So the biggest thing you want to watch for on our problems is these kind of terms in here, okay? Where that base matches that result, and you basically ended up with those exponents. So not real bad. So now what we'll do, we'll start out with a bunch of logs, and we're going to try to turn them into a single logarithm. So we're going to go the other way.
So for that hold on, Mr. Rathbone, I'm still.
You want this page?
Right. Yeah, I'm still writing the last one.
Okay.
Like just a couple numbers, but so that turned into just a negative 5/4 for.
Because this log C of C part equaled 1.
Oh, so we just get rid of the log too?
Because remember we did the log heart of a heart the other day, and we said that equaled 1.
Oh, it doesn't equal one log heart. It's just a 1.
Right.
Okay. Okay, I'm done writing. Thanks.
All right, so like I said, we're going to go the other way, and we're going to express as a single logarithm. Okay, so these started at about number 12. So they're giving me log C of 22 plus a log C of 45. And then let me check how far they went on that. Alrighty, so since they're being added, we're going to rewrite them as a product. So this will be log C of 22 times 45. And then it'll have us even go to one step further and actually multiply that and see what we get. So let me see, what's that, 22 times 45? That gives me a log base C of 990. All right, y'all, this one has a log 1,000 minus a log of 100. So the first step, they actually have you simplify this. So I know that this will be log. Since they're being subtracted, we're going to have to write this as division. On top will be the 1,000. On bottom will be the 100. So subtraction gets rewritten as division, and up here addition always gets rewritten as multiplication. Now, I can actually divide that 1,000 by that 100. So if you divide 1,000 by 100, you get a log 10. Now, that would be the first answer. And then they have you simplify that. So what would the log of 10 give us? Because remember, what's the base? If there's no number here, remember the base is automatically a 10.
Simplifies to
10.
1.
Oh, what'd you just say?
1.
1, bam.
You just hit log 10 in your calculator and hit enter and it'll tell you.
Exactly. But anytime that base matches that result, remember, you will get a 1 on that. So that one has two answers. They have you write it as a log first, and then they go on and simplify that into a 1.
So the whole answer, one of them could be just a 1.
Well, it's going to want both of these answers, though, okay?
Okay.
It's one of them parts where they say, oh, well, you got a log 10. You can simplify that and get me a 1 out of it. So in the first blank, they will have the log there, and all you're going to put in is 10. All right, so here's a fun one. 1/4 log base c of x plus 5 log c of y minus 4 log c of x. Now this one's got a lot of crazy moves we're going to do. But the first thing, you see all these exponents? Since that was my last step before, it's my first step I'm going to do now. I'm going to move all the exponents up behind the variables. So this will give you log c x to the 1/4 plus log c of y to the 5th minus log c of x to the 4th. So you're going in pretty much exactly the reverse order. So the first thing is always take them exponents up. Now, if they're being added, they're going to go to the top of the fraction. If they're being subtracted, they're going to go to the bottom. So this is a big log C now. On top is an x to the 1/4 times the y to the 5th. So we rewrite the adding on top as a product. And then since this is minus log C of x to the 4, that means that x to the 4 goes to the bottom. So we're pretty much done, y'all, except one thing. We need to simplify this. We are not allowed to have x's on top and x's on the bottom. Okay, so we need to simplify the x's. So I'm going to subtract the exponents, but since the 4 is bigger in the bottom, I'm going to take that 4 and subtract the exponent on top, which is a 1/4. Okay, you always subtract the smaller exponent from the larger, and then that answer will stay where the larger exponent was. So let's see what is a 4 minus 1/4.
3 3/4.
So I'm going to hit math and enter twice because I want that to be a fraction. And what's that? 15/4?
Yep.
All right, so I get 15/4. So I'm going to have my log C. The y to the 5th is on top. And on bottom, we said that was x to the 15/4. Now, I got y's on top, x's on bottom. None of those will simplify, so we are done. So just remember, anytime you get fractional answers like this, you're not allowed to have the same variable on the top and on the bottom. You got to simplify them by subtracting them out. All right, so they're getting pretty interesting now, right? Just bringing back memories.
This is the first time, well, technically, I guess Wednesday was the first time I'd ever done
Aspirin. That's a lot of steps.
Oh yeah. Oh, let me see. I think I'm going to go to 16 next. 16 has ln in parentheses x squared plus 6x plus 8. We're subtracting ln x plus 4. So exponents are already brought up on everything. There's nothing I can do to that, so I'm going to go straight into rewriting it. Since it's being subtracted, I'm going to rewrite it as a quotient. So it's going to be ln. On top will be the x squared plus 6x plus 8 all over the bottom, which is the x plus 4. So once again, anything negative has to go to the bottom of the fraction. So now we need to simplify this. So I'll give y'all a clue. To simplify that top, I'm going to have to factor it. The bottom, x plus 4, I cannot do anything to, so I'm going to bring it down. Now, if this is going to simplify, y'all, when I'm done factoring this, I better have an x plus 4 up here. Because if I don't get an x plus 4 on top, nothing's going to cancel and simplify, okay? So we got an x squared. That means we got an x in front of both of these. That 8 is positive, so that means both signs will be positive like the middle number. The middle number 6. Can you find me factors of the last number 8 that equals 6?
2 plus 4.
2.
4, so I'm going to make me a 2 and a 4. So now I got an x plus 2, x plus 4 over x plus 4. So guess what? We're going to cross out those x plus 4s because they cancel. So my final answer is the ln of x plus 2. Now, if you have to write this in MATLAB, make sure you put that x plus 2 in parentheses because it's all being affected by that ln, okay? Now, we'll say, hey, if y'all are weak at factoring, y'all got my factor program on there, so hit program. Go to number 7 on mine is factor. Whoops, factor. I can hit enter, and I would put numbers in just like you did the quad. So I would put in a 1, 6, 8, and when I put in my 1, 6, 8, it factors it into the x plus 4, x plus 2. And then
Oh, that is spiffy.
Okay,
I
so
like that.
Right.
it's just like the quad, except it does the factoring part instead of solving it. So
How long has that been on there and I haven't known about it?
I
This whole
know.
time.
Unfortunately, I was able to use it for the test,
Yeah.
so that means you probably could have too.
Yeah, and there wasn't a real, maybe the domains were one of the only places where you could actually do that, because what y'all were finding out were the answers, so everything y'all wanted was the quad, you know, so, because it took us all the way to the zeros and the answers, so.
The good news is we've kind of learned to deal with and play with factoring, so.
There you go. Once you learn the concept, then we let you break it down, right?
Right, I
That would
appreciate
have
that.
been helpful last semester. That would have been really helpful last
Well,
semester.
then you wouldn't have learned.
Oh yeah, when you had foundations, it would have been big help. And then this one's an x
Oh, Miss
squared
McConnell was great with teaching it, but oh my God, that program would have been really helpful.
All right, and let's see. Once again, I got these trinomials and binomials, but nothing I can do, so I'm going to rewrite this as division since it's got subtraction there. So it's going to be a big log on top, x squared plus 8x plus 12, and that'll be divided by the x squared minus 36. So I will say this one, the top will factor and the bottom will factor. So if you're using my factor program, you would put in a 1, 8, and 12 on top. That would give you x plus 6, x plus 2. Factors at 12 that add to get 8 would be 2 and 6. The bottom is perfect squares. If you factor that, it's going to be a 1, 0, negative 36. Perfect squares factor into x plus 6, x minus 6. So remember these perfect squares always gave you the conjugates. But now that everything's rewritten, guess what I'm going to do?
Cancel.
Yeah, I'm going to cancel those x plus 6's out. So my final answer would be the log of the x plus 2 over x minus 6. Now, it probably wouldn't need parentheses on this one because it knows the whole fraction is being affected by the log. There you go. That was 9-5. Let me see. Oh, I still got
I
quite a bit of
appreciate
time.
how you gave us examples from our homework pretty much, so we can figure out the same types of problems.
Yeah, so you got these ones we're doing in here, and then I sent out a video already doing these on the without the lecture part, you know.
You're
All
on
right,
it.
well, here's what it's all been coming down to is 9.6. Solving exponential and logarithmic equations. So I'm going to sort of give you like little steps when I get each style of equation. So the first step, the little property I'm going to show you is what we call the base exponent property. So this tells me if a to the x equals a to the y. So notice the bases are the same. The only thing different is the exponents. But y'all, if two sides are equal and their bases are equal, then that means x has to equal y. So if this was 5 to the x equals 5 to the second, that means x would equal 2 because those exponents would be equal. Alrighty, so steps to solving exponential. All right, so the first thing, if possible, rewrite each side using the same base. So that we could utilize that property there, okay? So if I'm able to rewrite each side using the same base, then set the exponents equal to each other. And that would be done once I set my equal, I have my x equal whatever, I'm done. If I'm not able to rewrite both sides using the same base, I've got to figure out how to bring those exponents down to the front so I can solve for them. In that case, I will take a ln of both sides. So take the ln of both sides. Isolate the variable. So basically, once you take the ln's, solve for that variable for me, okay? So here we go. We're going to solve for x. So number one, I have 5 to the x equals 125. So you got to think to yourself, can I rewrite that 125 using the 5 for the base? So can I rewrite 125 using base of 5? So let's see, bringing down that left side. So if I'm going to rewrite 5 as my base, how many times can I multiply 5 times itself to get 125? So we got what, 5 times 5, that's twice, that's 25. 25 times 5 is 125, so that was 3 times. So exponent would be 3. But now, since I was able to rewrite 125 using the 5, these bases now match. So the bases match, which means my answer is x equals 3. That's our whole goal. Once we can match them up, or we're done, we just set the exponents equal and move on, okay?
That ain't bad at all.
No, they get a little trickier. They try to get a little trickier. Let's try this one. Number 2. 2 to the 5x equals 8. So I would ask myself, can I rewrite that 8? Using base 2. So I would have 2 to the 5x over
I
here.
would think so.
So let's think. What do you got? 2 times 2 is what, 4?
And then you'd have 2 to the third.
And then 4 times 2?
4 times 2 is 8.
So I'm going to get 2 to the
So
third,
you'd have
like you
2 to
said.
the third.
Which means now the bases match. So I know that the 5x has to equal 3. So now this one has a little bit of work. I can solve this doing one move. I'm going to divide both sides by that 5 in front of that x. So it looks like I get x equals what? 3 over 5. So check this out. If you put that 3 over 5 in for the x's, the 5's cancel, and 2 to the third power will equal 8. All right, I'm going to throw the curveball. How about this? 4 to the x equals 19. Can I rewrite 19 using a base 4?
No.
No.
No, because 4 times 4 is 16, and then it gets way bigger than that. So since I cannot rewrite this, we have to take ln of both sides. So that's going to give me a ln of 4 to the x equals a ln of 19. And remember, what I do to one side of an equation is why I'm having to do the ln to that other side of that equation, okay? Let me see if y'all can guess my next move. Over here, you got an ln 4 to the x. Over here, you got an ln of 19. Y'all know we don't like these exponents sitting up here like that, do we?
You're going to move that exponent.
I'm going to move that exponent very front of this. So that I get a x ln 4 equals the ln of 19.
Or 19.
So here's the question. I need to get this x over here all by itself. So since x is being multiplied by the ln of 4, I'm going to divide both sides by the ln of 4. So this side will equal what, an ln of 19 divided by my ln of 4. So notice the ln of 4's cancel on that left side, leaving me my x like I wanted. And let's see, let me see.
And then I don't know if that.
It wants me to round to 4 decimal places. So remember, when you do these, close these parentheses on these LNs when you do them, okay? So we have a LN of 19, close parentheses, divided by the LN of 4, close parentheses. So remember, we're rounding out, what I say, 4 decimal places. So that's going to be a 2.12. Oh, look at that. That's going to round on up,
4.
ain't it? Because that 9's going to round up. So that 3 must become what, a 40. Okay. So check this out. When you can rewrite them, you're going to get nice answers. Might be a fraction, but it won't be too bad. When you cannot rewrite them, you're going to get a nice decimal answer, okay? All right, 4 to the 7x minus 1 equals 16. Can you rewrite this 16 using a base 4?
Yes.
Okay, so I'm going to definitely do that. So I'm going to bring down that 4 to the 7x minus 1, and that'll equal 4 squared, actually. So now I know what's happening. I got bases match. So bases match means my exponents are equal. So we know that 7x minus 1 has to equal 2.
2.
And then y'all, we got what, a couple more moves on this to get the x by itself.
Now we'll first need to add 1 to both sides.
There you go. So that's going to give me what, a 7x, and 2 and 1 is what, a 3.
Last I checked, it was.
And then what y'all doing, dividing?
Mm-hmm.
And then I don't think we can simplify that. So x will be
No.
a.
Both those are prime numbers, so x is 3/7.
Now check it out. If you put the 3/7 in here, the 7's cancel. 3 minus 1 is 2, and 4 to the 2nd power is 16. So you can sort of check them when you put them answers back if you wanted to, okay? I like these kind of equations, though. They was always fun to me. All right, how about this? 3 to the x equals 2.
Now, that one we cannot rewrite.
Cannot rewrite it, so the first move I'm going to do is take ln of both sides, which gives me a ln of 3 to the x is going to equal a ln of the 2. So the question of the day, next move.
Move the X in front of the ln.
Yeah.
3.
Yeah, we got to deal with that.
And the reason we're doing that because we're solving for that x, and we can't do it while it's up there in the exponent spot. So good job. So that's an x ln 3 equals ln 2. One more move, y'all, and we're done. We're going to divide both sides by ln of 3. So that x is approximately.
The x ln 3.
Now, this would be what we would call the exact answer, ln 2 over ln of 3. But we want a decimal approximation, so let's punch that in. ln of 2, close parentheses, divided by ln of 3, close parentheses. And
0.6309.
6309, perfect.
Yep.
Okay.
So it's going to ask us to put in both those answers?
No, I was just saying in the real world, if they said they want an exact answer, that's what they would be wanting, the ln 2 over ln 3. But we were just wanting the decimal approximation, so we went on all the way down. Sort of like.
So what would you
Say again?
What would you use this for, like in real life?
engineering and you use a lot of LN stuff in those business equations. Really the E they use a lot of, but so they're going to have equations like this. P of T equals my initial E to the KT type stuff. So if you ever solve these for the time, the only way to bring this stuff down is doing them LNs to it, and it brings those exponents down to where I can solve them and stuff. So really this would be, oh, ain't you doing physics? I mean, chemistry?
Mhm.
That would be the growth and decay rate stuff you might deal with in future life.
Okay.
Because I'm sure you're going to deal with half-life and all that fun stuff.
Yep.
So when we hit 9.7, it'll sure to show you a few examples doing that.
Okay.
With the decay and the growth rate and stuff. Alrighty, so let me see. This would be my number 6. This is a tricky one. I got 10 to the negative x equals 6 to the 4x. So I'm going to tell you why it's tricky, because they got x's on both sides. So I don't think I can rewrite these at the same base. Y'all with me? One's got a 10, hell, one's got a 6. Ain't nothing we can do to that. So we're going to take
Nope.
LN of both sides. So that'll give me a LN of 10 to the negative x equals LN of 6 to the 4x. So I wonder what I could do to that next.
Well, next thing we got to do is move them exponents, don't we?
Damn, that's it. That's it. So I get a negative x times the ln of 10 equals 4x times the ln of 6. So now what we really need to do, because you got an x here and an x there,
We got to get both those x's on the same side of that equals.
bam. So how about we add this negative one to both sides? Add an x ln 10 to both sides. So notice what I get. I get a 0 over here. But on this side, I get 4x ln 6 plus x ln 10. So I wonder if there's a way that I can turn these two x's into 1x. And y'all, what we're going to do is treat these as a GCF. What do both of these have in common?
X.
That x. So what we're going to do is factor that x out like a GCF and put everything else into parentheses. Well, if I take the x out of the first term, that's going to give me a 4ln 6. Plus, I factor out the x out of the second term, that's going to leave you a ln 10. So here's what I got set up. I got this x being multiplied by all this. We're going to divide both sides by all this part of this. And then that's going to equal the other side divided. So you got to think, anytime you got variables on different sides and they're not like terms, so I couldn't actually add them together up here. The only way to get them two x's into one is doing that greatest common factor stuff. Factor it out, okay? All right, now let me put the 4ln 6 plus ln 10 here. Well, this side's nice because they cancel away and I get my x. Well, hell, what's the answer?
4ln 6 plus ln 10.
Oh, but look at this side. What are you doing to this side?
Oh, we're dividing.
Okay, keep going. You're dividing 0 by this stuff right here.
Yeah.
So what's that going to give me?
Well, you can't divide 0.
Oh, no. Try this. Watch this.
A 0?
0. Okay. 0 divided by anything is a big O 0, right?
0.
0.
See, I had it all mixed up because Casey was thinking if that 0 was on the bottom.
You can't divide by 0. That's ridiculous.
Right, there you go. So that's sort of tricky because you had to sort of work that X onto the same side, okay? All right, here comes one of those with the E. E to the T equals 320. Don't that just make you want to say phone home?
Mm-hmm.
Oh, y'all are too young for that movie.
I love that movie. I'm not.
No.
I think that was like back in the 80s.
That was one of my favorites as a kid.
Mm-hmm.
I always wished I could make my bicycle fly like that.
Heard that. So, can you rewrite that 320 using the E?
I'm going to go with a no.
I'm going to go with a no. So that means I'm going to take my LNs. So ln of E to the T equals the ln of your 320. And y'all know my next move. I'm going to bring that T right down to the front. T ln E equals the ln of 320. So let me ask y'all this. Before I divided by all this stuff, I'm not dividing by this ln of E because ask your calculator what the ln of E equals.
How do I do that?
Number by the 4 is the ln,
Yeah, I found that.
and then hit second divide to get the
1.
E.
It's 1.
So this is equal to 1 right here, right?
Okay.
So the T is going to come down, and all we got to do is figure out what the ln of a 320 is going to give us. And that's going to give us a 5.76. I think that's an 8.3. 8, and the
Yeah.
3 will stay at 3. Okay. All right, y'all got that one?
Mhm.
So let me take you through the last of these jacked up exponentials, and then I'll show you a log one we can knock out. This one has 15 to the x equals 5 to the x plus 2. So I'm not going to attempt to rewrite 5s and 15s. I know I couldn't do that anyway, so I'm going to take ln of both sides. So you see, ln is my magic tool to bring those exponents down. So ln of 15 to the x equals ln of 5 to the x plus 2. Now be careful on this, and because I'm going to bring this x down to the front, I get an x ln 15. Now y'all watch what I'm going to do here, because I'm bringing the x plus 2, the whole thing down. So on that side, I'm going to put the x plus 2 in parentheses, and then I got what, a ln 5. Since you got 2 parts up here for the exponent, both of them will have to be distributed with the ln of 5. And y'all, that's my next move. I'm going to distribute both of these so that I get a x ln 5 plus a 2 ln 5. So now remember, what are we solving for? The x's. So all these x's need to be on one side. So how about we subtract x ln 5 from both sides?
Sounds good to me.
So yeah, this is the fun algebra y'all been waiting on all year. So x ln
So, x on
15.
15 minus x on 5, wouldn't that be XLN10.
L-N-10, right?
And then this is 2ln5. All right, so what are y'all trying to do?
Was it
Oh,
just
remember,
ln of 10?
but remember, these LNs are looking for exponents. They're not really 15 minus 5, remember. Those are exponents. So,
Oh, so
yeah, you won't be able to subtract.
Okay.
But what I want to know is you got two x's I need to turn into 1. Can I do that GCF stuff again?
Yeah.
So let's do that. We're going to break out the x, and in parentheses, we'll put the ln15 minus the ln5. That's going to equal my other side, which is a 2 ln5. All right, now we're going to divide both sides by ln15 minus ln of 5. So I wonder if Danielle's hubby told her this would be so fun doing the logs. All right, so
Yes,
this
sure.
side we're happy. That all canceled, right? So I got my x. Now, y'all, when you do this
Just an
side,
F.
so y'all do this side, be careful. I'm going to close those parentheses, but I'm going to use extra parentheses on the bottom because I got more than one part. So on the calculator, I'm going to do 2 ln 5, close those parentheses. So let me bring that over here. Divided by big parentheses, ln 15, close its little parentheses, minus ln 5, close its parentheses, and then close the main parentheses on the bottom. So everywhere you see parentheses is what you would do in the calculator for that, but you got to have the main big ones. So when we hit enter, we should get 2.9. Oh hell, let's see. That's gonna be 9300,
I
ain't it?
got an error.
Oh, you got an error on yours? All right, hit the go to. Go to number 2 and go to.
Okay.
Where's it blinking? Oh, I can't see that real good.
You didn't open the parentheses
Yeah.
in the first place.
Right after your division, insert a left parenthesis right in front of your ln.
How do I?
So go right where you need to put it and hit second delete because that'll let you insert, and then you just put in a parenthesis and you're done.
Okay, there it goes.
Yeah, so anytime you get an error like that, if you'll go to, it'll blink. And what it was doing is it was blinking on that last parenthesis because it didn't have an opening parenthesis.
Ah,
All right, so here we go. We're going to solve logarithmic. So to solve logarithmic equations, well, the main thing you do is you rewrite these as exponential. And then once I rewrite them as exponential, I'm going to try, can we rewrite with same base? That'll be a yes or no. If not, I'm going to take ln of both sides. If we can't rewrite. And after that, you just solve for that variable and be done. So we're going to solve for x again. Oh, and this starts at about number 10, I think. So I got log base 5 of x equals 4. So remember, I'm going to rewrite it. 5 is my base, so I'm going to write my base 5. So that's your base. Remember, 4 is the exponent, so that's going to give me 5 to the 4th is going to equal my result of x. So hell, this one's nice because the variable is the result. And to find that, I'm just going to figure out what 5 times 5 times 5 times 5 equals. So let's see what 5 to the 4th equals.
625.
625. So x is 625. These just ain't that bad, are they?
Not
How about
really.
this? Log of x equals -3. So this could be a sort of a curveball because I don't see a base there. So what
Our
number
base
would
is
y'all, what was that?
10.
10, perfect.
Anytime
So
there's
I
another
got-
base here, it's understood to be 10.
So I got 10 to the exponent of -3 is going to equal my x. And then we can punch that in. Now remember, since that's a negative exponent, you better get a decimal answer on that.
0.001.
So 0.001, you said?
Yeah.
Equals my, yep, that's it, perfect.
These ain't bad at all.
Oh no, I love these. Log base 5 of 5x minus 5 equals 2.
Hey, Mr. Raffin,
Uh-huh.
I'm gonna have to leave the class. My internet's getting sketchy where I'm at.
Okay, so I'll send a video out later, probably about 3 or 4 o'clock.
Okay, I appreciate it. I'm on the road right now, so I'm not able to take notes. That's why I was wondering if you were gonna record today's session.
Yeah, we got you covered.
So I will see you guys Monday.
Yeah.
Have a good day, Danielle.
All right, we'll see y'all later. All righty, y'all. So on this one, my base is the 5. So I'm gonna take my 5. My exponent is the 2. And 5 to the second is going to equal 5x minus 5. Also, one we can actually solve. So I think the first thing we'll do is turn that 5 to the second power into a 25.
Yeah.
Equals my 5x minus 5. All right, what y'all doing next?
Well, now this is what we did in high school algebra. We're just going to solve for that x.
There you
So we're
go.
going to subtract 5 from both sides, and then we'll divide.
So that's going to give me what? 30 equals 5x, and then divide by the 5.
6.
And bam, I get a 6 on that, and good job. And that makes sense, because if you put a 6 in for this x, 5 times 6 is 30. 30 minus 5 is 25. And I know that 5 to the second power is equal to 25. Okay? Oh, y'all, they're getting even better. I love this one now. 13. So I think I'll do this one, and then let me see. That'll leave us just a few to cover next week. So y'all should be able to work 9.6 down to this number 13. So let me give y'all a fun one. Here is a log x plus a log x minus 3 equals 1. Oh, these are almost my favorites too. Because the first thing I can do before I can convert these logs into exponential, I got to have just one log there. So we want to write the left side as a single log, like the stuff we did earlier. So there's that 9.5 stuff that I was telling you about. So since these are being added, we're going to write that as a product, x times x minus 3. All that's going to equal 1. And I'm going to go a step further, and actually let's multiply this stuff out right here. So I get a log. So let's see, if we distribute the x times the x would give me an x squared. And then x times that -3 gives me a -3x.
-3, right.
And all that's still equal to 1. So now you can't do anything else to it. So we're going to now rewrite as exponential. So, what's my base?
-3.
Over you. Oh no, remember my base, my log don't really have a base down there. So you're
So
going
it's
to
a
say
10.
that's my 10. There you go. So 10 is my base. My exponent is 1. That's going to equal the result of an x squared minus 3x. Oh, so this one is actually quadratic when we solve it. So we need everything on one side equal to 0, and then we can use the quad.
Well, first of all, we know that 10 to the 1 is just 10.
There you go. So
So
basically,
we
I'm
can
just going to
take care
subtract
of
10.
that right there.
So you get your 0, and that's going to equal x squared minus 3x minus 10. So at this point, if you want to, you can use the quad. A would be 1, B would be -3, C would be -10. Or y'all, that would have factored pretty quick. That would have factored into 5 and 2 would have gave you a 3. So what I need now is the final answers quad would have gave me would have been a +5 and a -2. So what would my final answer be? Well, this goes back to yesterday, but let me see. So if I put these answers in for this log, I'm going to check that. I can put a 5 in and take the log of it. Watch this, log of 5. That's going to give me a number. What about that -2? If I take the log of that -2, y'all don't remember what happened yesterday? Oh,
Oh, that's the negative.
Doesn't
I
like
get those
that
non-real
-2.
answers, right? Which means we cannot accept any answers where you take a log of a negative number, because it's not going to give us a real answer. So the only answer on this would be
Leave the
a
x
5.
equals 5.
So,
So
anytime we have a negative, basically, we're going to disregard it if there's two
well,
answers.
let me show you what happens. What if I had this log of x plus 5 or something? Now, when I put a -2 in for that, it don't make this part negative. So I'm still taking a log of a positive number. But anytime you get in here and it makes this part negative, then you got to kick that answer out. Okay? So just check your answer and see if it's
So
going
we
to make
should
it
just
negative.
check them both.
Okay? But
So
most
you
of the
put
ones,
the 5 and the -2, you replace them with what?
no, the only answer I keep is that 5. That -2
Yeah,
answer.
but when you went to check them, you put them in.
Oh, so I went up here and I had a log right here.
Of them.
So since this log was by itself, I went in there and said, well, I
Oh.
can do the log of 5 because that's positive, but I can't do the log of a -2 because that made it non-real. Now over here,
Okay.
you put the 5. 5 minus 3 still gave me 2, so that would have been good also. But then the -2 minus 3 would have still made that a -5. So -2 wouldn't work on either one of them logs. So just make sure when you're done that your log is not trying to take a log of a negative number.
Okay.
So if it's a logarithmic equation, check them and make sure those negative answers don't affect it, okay?
Mhm.
All right, so that's enough for today. So that'll take you almost through 9.6. Toward the end, there were some good log ones, you know, that we'll knock out Monday. And then we'll do the 9.6. It's not very long, I think like 5 questions. It's just getting y'all used to that new formula. So I'm gonna stop this recording. All right, where did I stop? Right.